Today we're going to start solving quadratics. Those are our trinomials in the specific form, ax squared plus bx plus c. The new thing you're going to notice is it says equals 0, so when you see that equal sign, you know you can start solving it. Another thing I want to point out, not going to happen to us today, but it does need to say equals 0, so if it doesn't say that, you need to solve for 0 right here and make that a 0 on there. So rearrange it. Some cool things you need to know before we get started. Every quadratic refers to a curve on the graph. This is called a parabola. So this curve on the graph is given by the equation that I have right here, x squared minus 8x plus 12. These x-intercepts, so this number right here and this number right here, those are called zeros. They call them zeros because they are when y is 0. They make when this right here is 0. So our x-intercepts mean you have no y value. Sometimes you call them solutions too, because it's what x equals to make it equal 0. They're also called roots, and when you think about roots, it's because of this x squared here. Anytime you have a square, you take the square root. You can find them using the factors with the zero product property. So I'm going to factor this in one all the way and show you how you would do it from scratch. And then below that, we're just going to practice them already factored and turning those factors into the solutions, into those zeros. So here's what you got to do. When you factor, this is a trinomial. So remember, you say the a times the c, so the first times the last. We're just talking about coefficients here. So 1 times 12 is 12. And then they need to add to the b, the middle number, -8. So I'm thinking already maybe -6 and -2. So you split that. So you've got -6x, -2x plus 12. So you go ahead and you do some factor by grouping. These have an x in common, which means an x minus 6 is left over. I need to pull out the negative that's in between, and 2 and 12 have a 2 in common. When I pull out -2, I get an x and a -6, because -2 times -6 is positive 12. So I have two factors. They are x minus 6, that stuff inside, and x minus 2, the stuff on the outsides. And now the new thing is they are equal to 0. So these are called the factors. And now I need to take them to the solutions, which is what x is equal to when I'm solving. So here's what the zero product property says. So I'm going to erase a little bit of what I've done here. Zero product property says that if I have two numbers and the answer is 0, so maybe I have 6x, the answer is 0, then that has to be, that x right there has to be 0, because 6 times 0 is 0. So it keeps going on, and it says, well, what if I had just an x and a y? So x times y equals 0. Well, then either x is 0, or y is 0, or maybe even they're both 0. So anytime I have two things multiplying together, I know the answer is going to be 0, then I know one of those has to be 0. So that's what we're going to use to solve this. That's called the zero product property. So you take your two factors. We said they were x minus 6 and x minus 2. And we're going to set them equal to 0 to see what would make those 0. So when you're solving this equation, you'd have to cancel out the minus 6 with the plus 6. So x must be equal to positive 6. And then if you want to cancel out the minus 2, you add 2. So you have x equals positive 2. Let me show you what this is doing when we go back into our equation right here. We pull up a calculator. So I said the answers were positive 6 and positive 2. These are also, if you notice, the zeros right here. We factored this exact graph right here. That if I plug this in for my x's, then I will get 0 out. Watch what I mean. So 6 squared minus 8 times 6 plus 12. Let me explain all those pieces again. I'm trying out my first x, which was 6. I plugged it in here, so 6 squared. Then I said minus 8 times my 6, so I plugged in the 6 again. Now I'm going to add 12. If this is the solution, then it should be equal to 0. And it is. But that's not the only number that makes this true. That's why we have another answer here. X is also 12. Or sorry, x is also 2. So we're going to plug in the 2 here and see what happens. 2 squared minus 8 times 2 plus 12. And that should also equal 0, and it does. So again, look what I did. This 2 and this 2 is just me plugging in here and here with my second answer. So you will get, most of the time, sometimes there's some exceptions, but you'll get as many answers as there are exponents. So if you have x squared, you're going to get 2 answers. If you just had 1x, you'd have 1 answer. If you had x cubed, you're probably looking for 3 answers. The way I wrote this is fine. Another way to write it is in our set notation, which means all of my answers are 6 and 2. So going back and relating this one more time, when you factor and you set those factors equal to 0, you get x equals 6 and x equals 2, which is 2 solutions. Those solutions are also called roots and zeros, and those zeros are referring to the x-intercepts on a graph. So if you are graphing this, you got x-intercepts at 2 and 6, just like we have up here. So that's what I need you to do for these bottom ones. It says, here are some factors, solve them for their zeros, and sketch a quick graph. So we're just going to basically sketch where those zeros are on the x-axis. So when you're solving it, remember you have 2 equations. You've got n minus 4 equals 0, and you've got n minus 8 equals 0, because one of these must be 0 in order for that to be 0. Maybe it's this one, or maybe it's this one. We'll see which one it is as we solve. We got to assume both of them are. So that means we need to add 4 here, so that's n equals positive 4. We've got to add 8 over here, so we've got n equals positive 8. You're going to notice some quick tricks. All you really are doing are switching the signs, and it's okay to start skipping steps. So we've got 2 answers. N is equal to 4, or n is equal to 8. So on your graph, we have 2 answers, one at 4, one at 8. So I just want you to do the quickest little graph of a U with x-intercepts at 4 and 8. I think I wrote 2 4s there, so 4 and 8. So let's try this next one. Got 2 factors. They have to be equal to 0. So let's figure out what would make that happen. So I need to subtract my 3, and I need to subtract my 1. So I have 2 answers here. So x is either equal to negative 3 or negative 1. I say either equal because you don't want to plug in one is negative 3 and one is negative 1. They're both answers to the problem, but you don't want to split it up. You want to either always plug in negative 3 for this one and this one, or always plug in negative 1 for this one and this one. You don't want to switch it up halfway through a check. So let's go and let's graph that. So at negative 1, I have a 0, and at negative 3, I also have a 0. So that's what our graph should look like. So here we are at another problem. Got something a little bit different on this one. We've got a coefficient suddenly. So let's see how that handles it. So we've got to set them both equal to 0. So I add my 8. This one I have to subtract my 4. I'm going to show a little bit more work because it's a 2-step. So, and then divide by my 7. So I've got a decimal answer, or just leave it as the fraction. That's easier. So x is equal to negative 4/7 and 8. So when I go to graph it, I need to approximate it just a little bit. I've got an answer over here at positive 8. And then I've got one here that's about a negative half. If you put it in your calculator, you can test the decimal of it. So 4/7. So just like that. All right, let's do one more like that, and then we'll skip ahead a couple. So on this next one, n minus 6 is equal to 0, and 2n plus 3 is equal to 0. So I need to add my 6, and I need to subtract my 3, and then divide by my 2. So I've got the answer. The answer is positive 6 and negative 3/2. So I go to my graph. So positive 6 over here, negative 3/2. That's negative 1.5, so about right here. And I graph it. Alright, you can keep practicing that, but I'm going to skip ahead to some that are a little bit different. It's actually the very next one, so that's not a big skip. Number 5, this one has a GCF. You see what happened here? So it was like we took something like v squared minus 6v. We said, oh, they have a GCF of v, and then a v minus 6 left over. So when you solve these, your first one's actually already solved. So either v is equal to 0, or v minus 6 is equal to 0. So that would be add 6, so positive 6. So this is just an example of one that would go through the origin. So either our answer is 0, or it's positive 6. And it just looks just like that. Alright. One I don't want you to confuse with that is one like number 10 here. Because you've got really 3 factors here. You've got 5, you've got v plus 1, and you've got v plus 6. but 5 is never equal to 0. So unless there's a variable there, it's not actually going to give you any answers. So this will give you an answer, this one will give you an answer, but that one won't because it did not have a variable. So let's finish solving this one since we started it. Subtract our 1, subtract our 6. So we have 2 answers here, one at -1 and one at -6, just like that. If you want to see one more GCF, let me do one more with you. So either my GCF is equal to 0, or my factor is my binomial. So add 7 for this one. This one, divide by 3. 0 divided by 3 is still 0. So what you're going to find is any GCF with a variable in it, it's always 0. So I've got my graph. Again, goes through the origin and goes through 7. So 0 and 7. All right, I have one more thing to pose to you here, and it is this upside down graph. So why is it opening upside down? And the reason is because A is negative. So this is something that can really help you out with multiple choice, eliminating answers. What are its x-intercepts? So we've got -4 and 2 where they hit on the x-axis. You could also give me the full coordinate there, -4, 0, and 2, 0. What are the solutions? What are the roots? What are the zeros? That's supposed to be a little bit of a trick. These are all actually the exact same thing. So it doesn't matter how I phrase this. I want these answers. And technically they should be in our set notation so you don't think I'm talking about a coordinate. I'm talking about 2 different places on the graph. And that is at -4 and at 2. And now I want you to think back and think, well, what would make those zeros? So what factors would make them? So what would make those equal to 0? So where you want to start is your x's. You know factors always start with x, and then they say plus or minus. If I get out a -4, then I must have been canceling out a +4. If I get a +2, then I must have been canceling out a -2. So the trick here is just switch your signs. All right.